All right, welcome back, everyone. Today we're going to talk about the part 2 of logarithmic functions. So in this section, you're going to learn how to determine the graph of a logarithmic function, how to determine logarithms with a calculator, and then how to use the change of base formula. So just like exponentials, logarithms are hard to graph because every number is going to give you a unique value. So when you start plugging in x values, you're never going to get the same number twice. There's no symmetry to speak of. If you plug in the wrong values, you'll often get a lot of decimals or fractions, things that can be very hard to graph. But like exponential functions, logarithmic functions all have similar shapes. Logs will never have a value for which x is less than or equal to 0. You cannot take the log of a negative number or the log of 0. Much like the exponential functions, the y value would never go below 0. For log functions, the x value will never go below 0. Now, the logarithm is going to be negative, so it's going to be less than 0 for any values where x is less than 1. So the function is always going to have negative values for x less than 1. And then log functions have integer y values and powers of the base. Okay, so if we're looking at this function over to the right, log base 2 of x, right, we can see this thing crosses at x equals 1 here. And we're looking for powers of the base, right? So the base is 2, 2 to the first power, so here's where 2 would be. Notice we have y equals 1. 2 to the second power, which is 4. Notice we get another one. If we continued on, 8 would be up to 3, and so on. So there are ways to recognize these graphs without having to pick points and plot them like you would in an exponential graph. So, for this example, we just want to determine the correct graph for y equals log base 3 of x. So we can eliminate 2 of them immediately. For a, we have values of x that are less than 0, so it can't be a. For b, we have the same problem, values where x is less than 0, and so it can't be b. And remember, we said that when x is less than 1, so between 0 and 1, the logarithm should be negative. Well, on this one, between 0 and 1, the logarithm is positive. So we can get rid of that one. C would be the correct answer. So notice that it has a similar shape to the picture from the previous slide. It's just log base 3 of x now. So it's going to be a little flatter if you graphed it. So let's take a moment and talk about your calculator. Everyone likely has a different calculator. This is the calculator that I would suggest you use or purchase. Should be no more than 20 bucks at Walmart. On this calculator, you can see the log and natural log buttons are found on the left-hand side. And notice that the second function for log is 10 to the x. And for natural log, it's e to the x. So those are the only 2 buttons that you need for these sections. So when you're trying to find logs in your calculator, it likely has 2 log buttons, log and natural log, right, in the second function. All these buttons are likely going to be used at some point throughout this course. Remember that it's important to use parentheses, and I'll talk about when to do that and how to use them. And it's going to be more important later. And also remember that each calculator is different, so use the following examples to make sure that you get on the calculator the same thing that I get. So we want to determine the following values using a calculator, and then we're just going to round to 4 decimal places. So the log of 23, you should get log 23 is equal to 1.3617. The natural log of 192.31, you should get 5.2591. the natural log of 0.735, you should get negative 0.3079. And then the log of negative 87. If you plug in log negative 87 to your calculator, likely you're going to get some kind of error. Remember, you cannot take the log of negative values. That graph doesn't exist past x equals 0. So this just doesn't have a solution. There is no value for log of negative 87. Keep that in mind. You cannot take the log of a negative number. So, though the calculator is set up only for base 10 and base e, right, all you have are the log buttons and the natural log buttons. It can find the value for any logarithm using the change of base formula. And so what you see here is you have log base a of x is equal to log of x divided by log of a, or the natural log of x divided by the natural log of a. Both of those ratios will work, right, but don't mix and match. Either use the log button or use the natural log button. You will see that I use natural log whenever I'm solving these problems. So if we want to find log base 3 of 17, right, what power do you raise 3 to get 17? Well, you can't just do that in your head. You need a calculator. And so to do that, you would find the log of 17 and the log of 3, and then just divide the two. If you then went back to your calculator and did 3 to the 2.5789 power, you're going to find that it should be about 17, barring any rounding issues that you have. Okay, so let's practice this. And this is where parentheses become important on your calculator. If you were to type in natural log of 17, and normally these calculators will do an open parentheses for you. If you type in natural log of 17 divided by natural log of 3, you're not going to get the right answer. What you need to do is make sure you include parentheses around both terms. So natural log of 17 divided by natural log of 3. You may wind up having more parentheses than necessary, but you'll get the right answer. If you don't close the parentheses when you divide, the calculator divides first and then does the log, and things don't work out correctly. So once again, use these next examples to make sure that you're getting the same numbers. We want to find log base 19 of 25. So we're going to use the change of base formula. And like I said, I like to use natural log. And so this is the same thing as the natural log of 25 divided by the natural log of 19. Well, the natural log of 25, 3.2189, and the natural log of 19, 2.9444. And so what you should get, 1.0932. And if you do 19 to that power, you'll see that it gives you about 25. So let's do the same thing for the second example, log base 12 of 1845. We're just going to say that's the natural log of 1845 over the natural log of 12. And if we divide both of those in our calculator, you should get 3.0264. So at the end of this lesson, you should be able to determine the graphs of logarithmic functions, or at least pick them out. Determine the values of common logarithms using your calculator, and determine the values of logarithms using the change of base formula.